Assalamualaikum, my name is Cik Nur Hasni binti Cik Azali and my group member is Mustika Rawiyah binti Azidin, Elvivan Daminon, Wajin Wei, Muhammad Dani Putra, Bishar Nizam, and we are from group 5. We will present about performance analysis of Q factor and polarization for GPON network using optic system.
My name is Elvivan Daminon, witnessing number CE200162, and now I will present the introduction. So in this project about the performance analysis of Q factor and polarization is crucial in the context of GPON, which is Gigabyte Passive Optical Network using an optic system. So a GPON network utilizes optical fiber infrastructure to provide high-speed broadband services to subscribe. The Q factor is a measure of signal quality representing the signal to noise ratio, which is SNR, and overall system performance. Other than that, it is influenced by factors such as optical power budget, optical signal to noise ratio, which is OSNR, diffusion, and nonlinear effect. For polarization, in a GPON network, polarization effect including polarization dependent losses, which is PDL, and polarization mode diffusion, PMD, can impact signal integrity and system performance. Besides that, by conducting a comprehensive performance analysis of Q factor and polarization, network operator can optimize signal quality, improve system performance, and maintain low error rates. This analysis is essential for ensuring reliable and high-quality broadband service in GPON network using an optic system.
My name is Mustika Rawiyah binti Azidin, metric number AE190003. The problem statement for our project is, in today's world, it can be said that having a high-speed data rate (HSDR) is a crucial necessity, and it is growing in line with client demand for various applications, such as for live streaming, video conferences, and also broadcasting. With the increasing demand for HSDR, the performance of data rate is observed to be slower as the consumption of data is continuously growing. Fiber bright splitting technique can be implemented to solve the issue of improving residential capacity in a gigabit passive optical network GPON. With less usage of fiber optic cables, this method is designed to lower the cost of deployment while increasing the number of people who can access high-speed internet. Nevertheless, the fiber bright splitting technique in a PON network needs to be implemented with careful planning and design in order for the network to remain dependable and successful in delivering a gigabit level speeds to all users. The problem is to maintain a balance between increasing residential capacity and maintaining the network performance and stability. Next, the objective for our project is, the first one is to design an error-free gigabit point-to-multipoint communication network with aid of fiber bright splitting technique, and the second one is to construct and simulate a gigabit passive optical network GPON performance using optic system software.
Salam sejahtera, Doktor. My name is Wajin Wei and my metric number is CE200165. So now I would like to present our group literature review. So now we are using the performance analysis of Q factor and polarization for GPON network using OptiSys as our reference for our group project. So the paper are actually designing an error-free gigabyte point-to-multipoint communication network using FPG technique. So the paper also discussed the importance of high-speed data rate (HSDR), and it is achieved by reducing the effect of inter-symbol interference of point-to-point, which is P2P communication, and the length of the optical fiber varies from 20 kilometers to 40 kilometers in the study. So it found that the maximum Q factor of 9.18044 at 20 kilometers, and beside that they are using laser filter for the group delay and shaping feature, and also use of pin photo detector for wider duplication region necessary for larger wavelength. So that's all from me. Thank you.
I will continue this presentation with methodology. So there are two stages in the simulation setup, which are the transmitter and receiver. And also I will explain about the fiber bright method. The optical source, optical pulse generator, and optical modulator make up the fiber optical transmitter's major parts. The amplitude of an optical wave is controlled using a Mach Zehnder modulator. The waveguide arms make up the input waveguide that is being used. The optical networks transmitter part employs a Mach Zehnder modulator. Another significant factor that is essential to optical fiber communication is optical polarization. So in this simulation, a continuous wave laser serves as the fiber optical transmitter. From the CW laser here, an electromagnetic wave was continuously released. While the optical attenuator, also known as the fiber optical attenuator, is used to lower the optical signal power level in the fiber optical in free space. The fields are temporarily and especially comprehensible in CW laser. Next, I will explain about the bright technique. The bright technique is defined as a process in which the lateral exposure causes a core of a single mode fiber, SMF, to produce a pattern in the periodic form of strong UV light. When exposed, it raises the refractive index of the core of the fiber, resulting in the fixed index modulation pattern known as grating. A small amount of light is reflected, and this amount varies with each periodic reflection. The bright condition occurs when the period of grating is approximately half the wavelength of the input light. The wavelength at which reflection occurs is known as the bright wavelength, and because this bright wavelength is essentially transparent in nature compared to the light wavelength, the light that is propagated through a grating can combine coherently from all reflected light signals when the bright wavelength is present. Lastly, the last part is receiver. The receiver is designed to receive the desired efficient signal with the least possible BER, bit error rate. It includes an eye diagram analyzer, bezel filter, and an optical regenerator for film photo detector. The bezel filter, which is also known as intrinsic detector, is used for group delay and shaping features, and it is very similar to the Gaussian filter. In contrast, the pin detector offers a bigger depletion region, which is required because longer wavelengths are permitted. The optical generator, often referred to as an optical repeater, it's a part of the optical fiber communication system that strengthens the digital optical signal. It is also known as an optical generator. An optical generator recognizes optical impulse and transform them into electrical signals. Then an eye diagram is used to analyze the high-speed communication system and short or long-range communication system. That's all from my part. Thank you.
Assalamualaikum and hello everyone. So my name is Muhammad Deni Putra bin Sharul Nizam, metric number CE200225. So today I want to explain about my project for optical communication. So this is my result and analysis for the performance analysis of Q factor and polarization for GPON network using optic system. So the test will be a different length. So in my test, I use three different length, which is 20 kilometer, 30 kilometer, and 40 kilometer. So we can see this the data for the analysis right here. So this is the eye diagram analyzer. So minimum BER is exponent negative 20, okay, in 20 kilometer. So we go to the 30 kilometer length, which is the minimum BER is exponent negative 18, and the 40 kilometer the minimum BER is exponent negative 15. So in the analysis part, we can see the maximum for the Q factor, minimum for the BER, uh, the eyes height, the threshold, and the last one is decision is instance. So this is the data that we can we can have. So, for this result analysis, so the standard for the rate of BER should be less than 10 exponent negative time for this distortion and noise-free communication. So the result for these three testing is it have a good result as per the standard of BR for delivering or transmitting an effective signal within the passive optical network. So that's all for my result and analysis for the project optical communication. So that's all for me. Thank you.
So the last part is conclusion, which is the performance analysis of Q factor and polarization using OptiSystem in a GPOE network provided valuable insights into signal quality, system optimization, and polarization related effects. By analyzing the Q factor, which is a measure of the quality of the optical signal, we can access the system performance in terms of signal degradation, noise, and overall transmission quality. A higher Q factor indicates better signal quality and lower error rates. Additionally, considering polarization-related effect is crucial in GPON networks, as the polarization state of the optical system can be affected by various factors such as fiber, birefringence, or misalignment of components. Polarization-related impairment can lead to signal degradation and increase bit error rate. So that's all for me, and thank you.